I want to start with a statistic that for me is extremely concerning. When you look at all adverse reactions to medications, these are pharmaceutics that have been proved for clinical use in the general population. And these are not just medications for women. It can be something as simple as a medication for a migraine, something for gastrointestinal concerns. When we consider all medications as a group released to the public, 80% of adverse reactions recorded for medications are recorded in women, not men. And that statistic alone should be something extremely concerning. Now, why is there that statistic? Is that statistic because women are underrepresented in clinical trials? That's partly the issue. But a key reason why there's such a disparity in the adverse reactions to medications once released into the human population is because of a lack of understanding of the differences between hormones and their roles and their impact on the human body between men and women. So I really want this statistic to be something that, shocks us into understanding why it is so important that we understand this subject matter. Drilling down a little bit further so that we can get into a clinical understanding of the importance here, this is a huge study, a study of over 80,000 university and college-age students, boys and girls, starting from high school, and they have been matched and normalized for all lifestyle factors, dietary factors, environmental factors, and we looked at concussions, the risk of concussion, and the impact in clinical outcomes of concussions. And what you see year over year is that in equal aged matched and normalized for all other parameters, the impact of concussions on girls is considerably and statistically higher than their male counterparts. And this is not because young female athletes were getting injured more frequently, far from it. This was literally something that clinicians could not explain. Why, when faced with an equal injury, young women, girls, adolescent girls were suffering the effects of concussions far, far more than their male counterparts. What made the matter even more interesting was that this disparity between the effect of concussions in women versus men, girls versus boys, was not there in prepubescent girls and not there in postmenopausal women. Again, this is by normalizing all factors. So in other words, when we take female athletes starting in prepubescent years, going through adolescence, through adulthood, and in postmenopausal years, this disparity of the impact of concussions is only there during their menstruating years. And that the impact and what really then for me as a hormonal geneticist and someone who specializes in this, that really drills the matter down even further, is that this impact, the symptoms, the disparity of risks and the disparity of outcome, not only is it only present in menstruating females, it's completely different depending on the time of cycle of the menstruating female, i.e., the impact of the concussions during follicular versus luteal phase is completely different. And just FYI, it's much more significant during the luteal phase. So here we've got the stage, pun intended, and the base of the discussion. It is this. We see that there is this huge disparity in pharmaceutic response between men and women. We see a defined, measurable, reportable clinical outcome, such as in concussions, is completely different between boys and girls, men and women, but yet that disparity is only present during the menstruating years, i.e. when there's active hormonal production, obviously in the subtype of hormones, your sex hormones, that disparity is not there in prepubescence, not there in postmenopausal, and that within the menstruating years, the disparity is further drilled down between the follicular versus luteal phase. What does this mean? It means that literally in menstruating women, we've got a definable biologic difference in cellular function, in human physiology, due to these incredibly important hormones. So what I want to do now is I want to demonstrate to you how far we can go in understanding this disparity and how much, if you do not consider the subject matter that I'm about to demonstrate to you, how poorly we are representing these health opportunities for our female population, and certainly as we go from premenopause into the menopausal years. Your genome, of course, as I mentioned, is the sum total of all of the genes that you've inherited. We all as human beings have essentially the same genome. I think that's clear to everyone. Male or female, ethnicity aside, we all share essentially the same operating manual of the human body. What makes us different, the little quirks, the little unique things, are these individual genetic variations. That's what makes us different. Now, these individual genetic variations, and I must admit, please forgive me, I'm getting a lot of background noise here, so it's a little bit for me, so bear with me as I try to get my bearings. These individual genetic variations in your genome interacts with your lifestyle, your diet, your environment. In other words, your variations explain why some of us in the audience are sensitive to gluten. Your variations explain why some of us, if you go to the mall and you pass through the perfumery section, you make a complete exit strategy because you get a headache if you pass through and you get all of those perfumes you're exposed to. So in other words, your gene variations contribute and explain a lot about how you respond to your diet, your lifestyle choices, and your environment. But here's what's key. Those very lifestyle choices, dietary choices, environmental exposures then interact with your genome to unfold how your body performs. So there's this intimate relationship between your genetics and these choices. Moreover, and this is an area that we're understanding more and more, and I'm actually quite happy to see a few booths here focusing on the subject, the impact of your microbiome, the impact of the billions and billions of cells, microbial cells that live within you, play a critical role in how your operating manual, your genome, unfolds how your body actually functions. And here's the link that obviously continues the discussion. What we've now understood, I mentioned earlier, and introducing the fact that hormones are the conductors of your genome orchestra. Hormones are the conductors telling your genes when to express, when to play, what symphony to play at the different times of the day, at the different times of the month, particularly in women with a monthly cycle. Your microbiome is intimately connected to your hormonal function, and your hormones are intimately connected to your microbiome. So, an incredible study by a colleague, Dr. Hamid Khalili, at the University of Harvard and Mass Gen Hospital, what he showed is that in women on birth control, oral contraception, women on oral contraception were significantly more at risk of leaky gut. He's a gastroenterologist, and the risk of leaky gut was due to the presence of oral contraceptives, particularly estrogen and estrogen metabolites in the gastro tract. So this connection between the microbiome and hormones is something that we're only now beginning to discover, extrapolate, and I might touch on that a little bit later on. The point here, though, is this. Because of this connectivity between your lifestyle, your diet, your environment, your microbiome, and how that impacts your gene expression, your cellular performance, which in turn impacts your cellular behavior, which in turn ultimately results in your health outcome. So as the basis, I'm going to pause now. We've got a thesis. The thesis is this. Each of you are individually unique based on your gene variations, your genetic makeup. The way your body manifests your genetic makeup is through the action of your hormones. Your hormones are the primary conductors, the primary conduits by which your genes are expressed. Each of your hormones, all of your hormones. And those hormones are intimately impacted by your lifestyle choices, your dietary choices, your environmental exposures, through the medium of your microbiome. And now we've got a cycle that if we actually are interested in true 360 human health, we have to be talking about these things collectively. And what I'm going to do today is to show you how a component of that, the hormonal component with genetics, plays out such that if I do my job, you will recognize that without these insights, we cannot be providing optimal health for ourselves, and particularly we could not be providing optimal health for females and for females going into their menopausal transition. So to summarize at this point in time, if your 22,000 odd genes, i.e. the genes that you've inherited from your parents, comprises your genome, then your hormones are the orchestral conductors of that incredible orchestra. And hence, of course, the image now that we start with. Your hormones are the conductors of your genome orchestra. I want to, for the scientists or for the doctors in the room, I'm going to drill down just for 2 minutes the actual scientific, sort of discourse of this. What you've got is your hormones, and that's any hormone, whether it's insulin, whether it's testosterone, whether it's estrogen, and this is whether it's an endogenous hormone or exogenously taken. All hormones do the job of being the conductors of the human genome through the following manner. The hormone is produced. It binds to an inactive hormone receptor. When that hormone and hormone receptor combined, it is now an active hormone receptor. Essentially, your hormone receptor is the doorway through which your hormone gets onto the stage. And I am the hormone, you are the instruments, the genes, and I'm now going to conduct this genomic orchestra. For that hormone to do its job of conducting the genomic orchestra, it has to get onto the stage of your genes, and that's the job of the receptor. But how then does a hormone, which is produced and is in the bloodstream, how does it impact different parts of the body differently? Why, when you were prepubescent and breast development has not yet occurred, and when your ovaries become activated and now you're producing progesterone, testosterone, estrogen, why did certain parts of your body change more than other parts of the body? And that's because there are cell type specific. When the hormone enters the cell, each cell has helpers for the hormone, which tells the hormone how to change the activity, how to change the symphony, how to be the conductor of the best cellular performance, whether it be a retinal cell, whether it be a breast mammary cell, whether it be a GI cell, a kidney cell, and so on and so forth. That unique cellular expression ultimately is then how hormones produced universally in the body can create different outcomes in different parts of the body. So of course, for most of you, all of you I'd assume, you've then seen the hormonal cycle, i.e. the menstrual hormonal cycle. There's a critical point here that I want to emphasize. And I think this is the point that is key for so many young women in their menstruating years prior to menopause, and that is being missed, is not being conveyed, and is not setting the stage for healthy transition, healthy menopausal transition. If this is your menstrual cycle, I want you to pay attention to something very carefully. We've got estrogen being produced, and this is of course an average menstrual cycle of about 28 days. What you see after the first 7 days in that green, if that's the color, your estrogen goes up, comes down if you do not become pregnant, of course. You hit repeat, start all over again. I want you to observe something. How long is estrogen elevated in the menstrual cycle? About 6 days of the month. So here's what you've got to understand. In the healthy female body, going through menstruation, in all of those beautiful years prior to even more beautiful years in menopause, every month, assuming that there's no external hormone, i.e. no birth control or exogenous hormones, the female body and female cellular behavior is based on exposure to estrogen for 6 days of the month. For only 6 days of the month does the genome of the female cell express itself in a unique manner, i.e. that it is conducted by estrogen for 6 days of the month. Only 6 days of the month. And keep in mind that with that exposure to estrogen, that cellular behavior is completely different to prior to the exposure to estrogen and after the exposure to estrogen. Hence the disparity of concussive risks in the follicular phase, the luteal phase. Hence the disparity in the concussive risk in prepubescent girls versus postmenopausal women. It is this change in cellular behavior leading to or coming from changes in gene expression that is correlated to the impact in all of the things I mentioned earlier. Now, if this is the case, I want to deposit or pose a question to you. What do you think happens when a young woman goes on birth control, i.e. oral contraception? What happens when, instead of 6 days of the month, she is now elevating her estrogens and is being exposed to those estrogens for 21 days of the month? And now a cellular symphony, a cellular behavior based on gene expression that was only designed for 6 days of the month is now happening for 21 days of the month. And my goodness, even more so now, many clinicians, what are we doing? We're actually telling young women they don't even need the bleed through period. You can actually take the pill back on back on back on back. And now we've got young women as young as 14 or 15 for 10, 15 years. Their cellular gene expression, and I want to emphasize this, that for optimal health was designed to be altered, i.e. to have that unique symphony of estrogen conductance for 6 days of the month. That young woman's body is now having it for 30 days, 28 days, month in, month out, year in, year out, and yet we're not going to expect a physiologic concern as she goes through her years and enters into menopause. It's actually, quite frankly, ridiculous. So what I'm going to do now in the few remaining minutes is I want to show you how we can then take genetics and really begin to extrapolate and illustrate why what we've been doing, first and foremost, why there's been this disparity in female health, why we need to change this disparity with a much more nuanced, a much more female-centric understanding of the human body. So what we've got here is, and this pointer, is that pointer actually showing up on the screen? No. What we've got here is your hormones are a cascade, and here I'm focusing on the sex hormones. What you see is that progesterone at the top is converted into testosterone. And yes, young woman, your testosterone, which you all have, it's not just a male thing, comes from your progesterone. But probably more remarkable to some of you is your estrogen is made from testosterone. If you are menstruating and if there's no external hormones, i.e. hormone replacement or birth control or hormone mimics, every molecule of estrogen in your body was first a molecule of testosterone. And every molecule of testosterone in your body was first a molecule of progesterone. It's a cascade. And by the way, this cascade that you see here is identical in women and men and women. It's the identical cascade. The only difference is, in a menstruating female, this cascade of moving from progesterone to testosterone to estrogen to the metabolites of estrogen and testosterone, in a menstruating female, it happens on average 1 month. In a male, post-pubescent, it happens every 24 hours, not every month. And so men, we actually go through this identical cascade every 24 hours, whereas in women, it happens every 28 to 30 days. But what we can do that is really cool as a geneticist is, for every step in that cascade, those things that you see in fuchsia, those are your genes. So for every step in this cascade, we've discovered the gene responsible for converting hormones into their metabolites. So what I can do now as a geneticist for the first time, I can actually take a look at every single one of those genes, and I can tell everyone in this audience what version of that gene you carry, which tells me how efficiently you are actually conducting the transmission from progesterone to testosterone to estrogen. Now, why is this important? Because, of course, if we look amongst ourselves, we all are familiar with the fact that if you take 20 young women, even if they were roommates, even if they were eating the same meals, sleeping the same hours, working out in the gym the same, their body types are different. Their bodies respond differently to things they do. Their bodies respond differently to diet. Their body responds differently to medications. And the point and the thesis of this is a key to the difference of this response comes because of these unique genes that we've been studying. Now, what we can further do is, for each of those genes, we can study the variations within you, and we can actually tell you the speed and the efficiency with which you are actually conducting this cascade. So now, all of a sudden, I can take any young woman, and just by looking at her gene signature, I can tell, is she the young woman that is rapidly converting her progesterone to testosterone, while not converting her testosterone to estrogen very much, while converting a lot of testosterone to DHT? She's an androdominant female. She's going to be that triathletic female. She's going to be that female that has just naturally a leaner body type, smaller breasted, leaner muscles, more striated muscle phenotype, versus the young woman who has the fast copy of conversion of testosterone into estrogen. She is more estrodominant, and we can look at what her body type looks like. Here's how this plays out. So for each of the steps that you just saw in the cascade, here's what we can do. This is what we call the testosterone or T intersection. And for anyone in this audience, we can rapidly determine your T intersection genes. To quickly explain, the stop signs are your genes. The stoplights are your genes. We all have these genes. What we have is different versions of those genes, and the versions are going to be shown as the stoplight sign. If you have a red sign on your stoplight, it means that you have the slow version of that gene. If you have a green light, it means you have the fast version of that gene. And of course, if you've got an amber light, you've got the medium version of that gene. So let's look at how that plays out. Here is a young woman that anyone, well, of course, I can actually pick out maybe who the young woman with this profile. That's what I do, thousands and thousands of these. So here's a young woman. What does she have? She has the fast version of the gene, CYP17A1, that converts her progesterone into testosterone. So every month, at about days 9 of her cycle, she starts to convert her progesterone into testosterone faster than her peers. Not only does she convert her progesterone faster into testosterone than her peers, she takes more of that testosterone and converts it into DHT. DHT is testosterone on testosterone. I like calling it my Jason Statham testosterone, right? So it's the really androgenized testosterone. She is doing that faster than her peers as well. And then she is simultaneously got the slowest version of the gene aromatase, CYP19A1, converting her testosterone into estrogen. So she is a very andro-dominant female. And let me make this clear. There is no way, no how this young woman is going to look like this young woman. This young woman has the slow conversion of progesterone into testosterone, the slow conversion of testosterone into DHT, and the fast conversion of testosterone into estrogen. She is going to be far more estrogenized. And the differences between these two young women are going to manifest potently in body type, and it's going to manifest potently in how she responds to all of the years that she was in the pill and into the years of menopause, if you did not know this, because here is the point. These gene pathways remain open during menopause. They remain open such that when you take bioidentical hormones or hormone replacement, which is a godsend for many. However, if you did not know that when you gave progesterone to one young woman, she's rapidly or not rapidly converting it into testosterone, and if you gave testosterone replacement, she is rapidly or not rapidly converting it into estrogen, you could provide a menopausal young woman with progesterone replacement and actually estrogenize her body far more than you anticipated. Or conversely, and this is the key, but the story continues actually, and we go into what we call the E phase of hormone metabolism. And that's where I will end my talk for today. Because every molecule of estrogen your body produces or that you take, whether it's during birth control or whether it's in hormone replacement, every molecule of estrogen must be metabolized into one of three metabolites. And one of those metabolites is the metabolite you want your estrogen to be metabolized into. Two of them is what you don't want your estrogens to be metabolized into, but every young woman, whether she be menstruating or whether she be menopausal, produces all three. And the ratio of this is determined by this gene profile. So here's what we have. You want to be this young woman, genetically, if you were blessed with it. You want to be the young woman who has the gene profile that whenever her body sees estrogens, be they endogenous estrogens or exogenous estrogens, you want to be the young woman that makes as much of the 2-hydroxyestrogen metabolite and as little of the 4 and 16-alpha hydroxy metabolite. But what if you're this young woman? What if you were genetically this young woman? And by the way, 15% of women are these young women. It's not 1% or 2%. And God forbid, what if you were this young woman? Now, every time this young woman sees estrogens, be it her endogenous or exogenous estrogens, she is every monthly cycle or even postmenopausally on hormone replacement, creating an exceedingly inflammatory environment for her body. And I'm actually going to stop there because this really capitalizes on the point. If we did not understand the uniqueness, the genetic uniqueness with which all human beings, but particularly in women, how does that young woman's body individually respond to hormones? How could we possibly hope to introduce and open the discussion of hormone replacement, hormone exposures, use of birth control, i.e. hormonal birth control, without an understanding of what we're actually doing to that young woman's body? And even in the endogenous state, we see a disparity of health outcomes as mentioned at the beginning of this talk. How then so for when we put in exogenous hormones and not consider what we've done to the young woman's body? And so this field of opening up, the field of the genetics of hormone or hormone genetics, is one that is really poised to completely change the way we actually understand the safe, because it can be safe. And it can be miraculously beautiful for a young woman to have her hormones optimized, be they in pre-menopausal years or in menopausal years. That's the point, that it is a godsend when these hormones are optimized. But we've got to know what we're doing, not at a generic level, but at a genetic level. And that was a Freudian slip. We've got to understand the individuality with which we provide these hormone treatment protocols, and that's what we're doing uniquely. I'm going to be in a plane very soon, and so I'm going to be rushing off after this talk. But my colleague here, Dr. Alessia, the tallest young woman in the room, I think, is going to be happy to answer any questions. And if you do have any questions, if you've got any follow-ups, all of you will have this talk actually in your kits, I believe. Please feel free to reach out to me. There was a lot more information, and I'd be happy to follow up with you.